Yeah, thank you. So basically, this topic is about open source project. It's something beyond research. So it's like we usually first do some research, but open source project is something that we want further impact. So we want to show our work to not only to the research community, but also the developer community, and to attract some stars in the GitHub, and to make a broader impact. So that's the main goal of open source project. So in today's presentation, so I will mainly share my experience of doing open source project, because I myself have been working with DouDizhu in the past 4 years, and I've been leading or co-leading several open source projects, and I know how it works, and I know how to do the advertisement for the open source project and how to attract impact. So basically, for about me, I love doing open source projects, but I also love doing research. So open source projects like I'm co-leading 6 machine learning open source projects during my PhD, and this project have already attracted 5K stars in total on GitHub. So which is actually a lot of impact. So basically, my open source project mainly focus on 2 areas. The first one is reinforcement learning in games, so which aims to develop some self-training reinforcement algorithms for poker games. And the other branch is the automated machine learning, so which is also related to reinforcement learning, because we usually apply reinforcement learning to do some search. Automated machine learning means we use some search algorithms to automatically discover the neural architecture, the pipeline of the machine learning algorithms. So from this topic, we have developed several packages, which is called, first is Auto Video, which is applying automation machine learning for video recognition. And second one is called TOS, so which is also an application on time series outlier detection, and PyOS, which is also on outlier detection, and BAD is like the object detection. So in today's agenda, I will introduce several things. The first, I will introduce how to make open source project impactful. So it's like a personal experience. So it's like how to start, how to plan. So because people usually want to, okay, we want to open source our code, but in order to make a bigger impact, we need a very detailed plan. So it's not like simply just put in the GitHub and people just wait and people will come to your repo. So that's not like this. So we need to actively plan it and develop it and expand the team and it's like attract more attention. And sometimes we also need to contact some media to do some advertisement. In this way, people will come and provide feedback and really use your package. And then you will be a healthy loop that you keep improving your packages. So basically, I will talk about how to start, how to plan, and how to push the progress, and how to attract users, and what problems and challenges or the roadblockers I have met when I developed the open source project. And secondly, I will just introduce a case study. So because one of the projects I developed from my first year of PhD is called the RLCard, so which is applying reinforcement learning to poker games such as the Texas Hold'em or DouDizhu in China. So I will give an overview of it, and also introduce a little bit of its follow-up work, which is called DouZero, which is also another open source package for Chinese poker DouDizhu. And finally, I will showcase a demo. So usually the open source project, usually we start from an idea. So maybe usually we need to think about these several axes. The first, what we want to do. So for example, in my first year when I developed my first package, so because at that time our group is collaborating with a poker company and we are doing research together. So at that chance, I feel like this is a good opportunity. There is no unified package about applying reinforcement for games. Although there are some packages about applying reinforcement in some Atari games or some video games, but there is no such package for a poker game. And poker game itself actually has a lot of popularity. It has a very large player base. So at that time, my goal is I want to develop a package about reinforcement for games. So, and second question when you think about is who are our users, right? So we don't want to make a package and it's just we itself or our lab have fun with it. So it's a too limited community. So we want to make it visible to a broad audience. So at that time, for example, for the package of RLCard, so I expect the users will mainly be researchers and the beginners who are interested in AI, because the beginners also usually account for maybe more than 90% of the community. Not many people are very excellent researchers. Most of the users could be just some master or undergrad students in a course, and maybe at a course they will use it as a course project or something. So this will have a much larger user base than research alone. And thirdly, so is the feasibility. So because actually developing an open source project is a very huge commitment. So we need to spend a lot of time and spend a lot of resources and to keep maintaining it. So it's not like a normal open source project for a research paper. For research paper, we only need to make it work and provide some instructions and some guidelines to ask the other researchers to reproduce the result. That will be good enough. But for open source project, the main thing is like we need to make it have very good usability. So with a very good API so that people can easily make use of it in their own research. So that question, so back to the question, so can I do this? So I feel like I can at that time because I have been doing reinforcement learning research for a year. So I'm very experienced in almost every aspect of reinforcement learning. And secondly, so do we have the people to do this? So yeah, because I'm in a research team, so I can enroll a team for this project with the help from DouZero. That's what I'm thinking about. And the third question is, who are my competitors? So because it's like running a company. So if in this specific area, we have a lot of competitors and they have already occupied all the market. So there's not many things we can do, right? So the fourth question is, we need to think about our competitors. So for the specific RLCard project, there are actually some competitors back in like 3 years ago. So first one is, which is a very popular one, which is called OpenAI Gym. So they kind of wrap up many different game environment. So such as Terry games and some simple text games and many others. So which is a very popular, at that time they have like the 10K or 20K stars or something. And in addition, there are some reinforcement projects such as the OpenAI baseline and some others. So but at that time when I look into this, I found that most of them actually focus on single agent reinforcement learning. So which means we only train one agent to do one thing. But actually, in many problems, there could be multi-agent. So poker gaming is actually a very desirable platform environment for multi-agent reinforcement learning. Think about the Texas Hold'em. We have multiple agent and we have multiple players, and each player can be an agent, and they need to play with each other. So that's the market that I think we can focus on, that the existing package cannot address. So my final decision is, okay, I aim to develop a package for poker games because people like playing poker. There are a very huge community, not only on the researchers, but also on the broad developers. And secondly, I'm doing poker AI project. So that's why I have some advantages. I know more than the other people, so I can do this. And finally, no other package is really focused on poker games. So there is some empty market that I can focus on. And second step is about the planning. So idea is not enough. Idea is cheap, right? So everyone can have an idea. So we need to really push this progress and to make it come true. So the planning phase, so from my experience, they have several questions we need to ask. The first one is, what will the package look like? So for example, if we want to develop a poker game package, so the first question is, okay, so what kind of poker game we need to involve? Right. So if we just involve some very rare poker games and no one play it, so it does not make sense. So of course we need to focus on the most popular one. So of course it's also impossible to cover all the poker games. There could be hundreds or thousands of poker games around the world. We cannot just implement them all. So we need to be focused. We need to select some very popular one. So that time I choose two. So the first one is Texas Hold'em, which is really, really popular around the Western world. And the other one is DouDizhu, which is very popular in the Eastern world, in China. So they both have maybe millions of active players every day. So so the package will look like, okay, we have several games and we have a unified interface, which means so for all the gaming environment, they will have the exactly same interface, so that when people develop some algorithms on Texas Hold'em, they can also be potentially applied to DouDizhu or some other games. And for the package, so we mainly target on making people easily train some reinforcement algorithms or agent on the games. So in order to realize this goal, so the next question is, okay, what jobs need to be done? So of course, the first one is about the interface design. So it's like we need to specify, okay, what is the input and what is the output, how the users interact with the package. That's the most important one. So especially if some users come and use your package and they find, okay, the interface is too complex, you need to pass a lot of arguments and it's not clear what the function returns, then they will just go away. So we need a very simple and straightforward interface so that we can make people addicted to this, make people really use it. And secondly, is the algorithm implementation, right? So this cannot be done only by me because it's okay for me to implement one game, but it's impossible for me to implement 5 games, 10 games, or even more games. So we need more people. So at that time, so I plan to talk with Dr. Hu, and we want to enroll some undergraduate, master, or even PhD students to help develop this package. And thirdly, we need to develop some use cases, right? So environment alone will not work because there are a lot of game implementations in the GitHub. So people have already implemented games. So what makes our package different is because we approach this from the machine learning perspective. And we can provide some concrete examples how people can train some reinforcement or machine learning algorithms on this environment in order to make it work. So that makes our package different from something developed by some game company. So because we are doing machine learning. And fourthly, in order to attract more attention, so I plan to do some GUI. So because for researchers or developers, it's okay to use some terminal-based interface. That's good enough. But to make even broader impact and make the media or some non-technical people understand what we're doing, so we may need a GUI. We may need to show that, okay, for example, this is our AI, and you can play with it and to experience this. So in this way, we can attract attention from the broader community. So, and finally, we need to make it more concrete. So what will do the project, and who will do the project, and how many people. So at that time, luckily, I talked to one of my lab mate and also one of my friend who is experiencing front end, and then we recruit 3 summer internship students from undergrad. So at that time, around 5 or 6 people are doing together for this project.
So I was asked one of the questions often by students, but it was not answered by your presentation, which is like, okay, they have programming experiences, they have computer science background. Okay. However, they have never really designed or implemented this kind of package or software level project. So any a very good API design and software infrastructure design that they could learn from either a package, should they register a tutorial, a package, learn from a package directly, or learn from some a textbook? What's your recommendation?
So my recommendation is actually just try to do this, just try to imitate others, right? So for example, if you want to develop some REPL for the game, for the reinforcement in games, there are actually some competitors, some similar REPLs. You can look into their interface, how they design it. So you can see that. So a common trend is so if the interface is very simple, then it will attract more attention. So simpler is better. So that's the common trend. So and then based on this, and we can design it from high level to low level. We can first design the interface from the user's perspective. It's like how users interact with our package. And then we can ask, okay, in order to implement this, realize this interface, what do we need to do internally? So that's the second question. So actually, when I developed the RLCard, actually at the first time, I'm also not very experienced in the interface stuff. So actually at that time, we just do it. We just try our best to design it, and we try to talk to some friends who are experienced in this kind of design. And then we just push it out. and we collect some feedback from the community. And then actually the community will push us to refine our interface. So that's my basic understanding. Just try to practice it. Practice makes perfect.
Yeah, that would be great. And the interface is just one thing. And what is more important is like the internal component interaction and the API, right?
Yeah.
Because like as a user, I only care about the interface or how it interacts with users. But I mean, what matters, however, the users may not have direct experiences, will be how the program really run in the backend. And this needs a lot of attention as well. So I believe at the time of when we design the software, we have to like really carefully not only design the API, but also get some senior people, experienced people to review the API design. It does not take a lot of their time, but it will be very helpful and significantly save the time for the future development.
Yeah, that's a really good suggestion. Yeah. Okay, yeah, I will continue. So next stage is once we have a plan, we do some development. So as I mentioned before, so we try to make the interface as simple as possible. So let me give you an example. So this is how we train how we interact with the environment in RLCard. So in this example, so we implement a very popular game which is called Blackjack. So it's a one-player poker game. So it's like so this interface is how we create an environment in RLCard. So it's like, for example, in this example, we just import an RLCard and we import a random agent. So which is just showcase how the agent can communicate or interact with the environment. And then we just simply call RLCard.make and pass a string to it. Okay, we tell the engine to create an environment called Blackjack. And then another interface is called environment.setAgent. So which just pass a list of agent to it. So in this case, there is only one agent because it's a single player game. So in some other games like Texas Hold'em, there could be more agent. Okay, then that's everything. So for a random agent, then you can print out some statistics of the game, such as how many actions there are and how many players there are and what is the state and action shape. State and action are two concepts in reinforcement. So which are actually some features extracted from the environment for training the neural network. And finally, the key part is actually how we generate some data from the environment. So we just call environment.run and we can obtain all the historical trajectories and also the result, which is called payoff of it. So you can see that the high-level interface is actually very straightforward. So of course, this is just a random agent, but we put in the README so that users can understand, okay, it's very simple. However, of course, if you want to train more advanced algorithms, you need to replace this random agent with your own agent and to really train the agent. So, and secondly, so we need to design some base classes. So because actually, especially when you develop a very large project, there could be many things that can be reused. So for example, in RLCard package, so we want to implement a lot of poker games. So although the rules of different poker games are very different, so there are always something in common. For example, most of them will use a deck of cards, deck of card maybe with 54 cards and or 2 decks of cards. So these things are very common. So in this case, we can just implement some base classes for the card object. And there are also many things in common. So the idea is like before we really do the development, we think about what could be in common so that we can save some efforts. And design a base class can also help us reduce the maintenance trouble in the future. So for example, if we implement a separate deck of cards for each poker game, so what if we find a bug in the deck of cards? Then we need to modify this function for all the games. It's a very miserable. So if we have a base class, we only need to change one place and to make it better. So for example, in RLCard, we designed 3 high-level base classes. The first is called game, so which define a common interface to implement a poker game. So the benefit of it is like once we settle down the base class, the others from the community can also follow the base class to implement their own games. So for example, when we first released this package, we only implement like 8 games. But later, some other community contributors, they try to develop their games. So, and now we have more than 10 games. So that's why we need a base class, so that we can kind of define the interface of the whole package and people can follow it. And then we define environment class, which is actually essentially a wrapper for the game. So the game itself is just some simple rules, but for the environment, it is more about how the agent should interact with the game. And finally, it is an agent. So agent is like how to do the learning, how to do the sampling data from the environment, and many others. So another benefit of the defining base class is actually we can easily distribute the workload. So for example, at my time, so actually for RLCard it's very straightforward. So there are a lot of games. So we just ask one person to take care of one game. So and then because we have already designed a base class, so people can easily follow the functions, the interface defined by the base class. So this way we can kind of minimize the invalid communication. And finally, we can finalize the project. So one thing that is very important is actually the unit and integrity test. So we try to write some test functions to test almost every line of code. The benefit of it is actually the long-term benefit. So because when you do the maintenance, so for example, if some other people submit a pull request and try to merge their code to the code base, so it may kind of affect the code from other perspective. So if we have a unit test, the automated testing can help us easily define, okay, whether this new feature will introduce any bugs. And of course, we need to some documentation, and we need to a very rich examples and to tell the users how to use it. So as you can see, so this is the overall of the packages. This is actually very different from the open source code of a research paper. So for research paper, it's straightforward. Maybe we just spend like a half an hour at most, okay, to clean the code and just open source in GitHub, and that's it. And if people ask us some questions, and we do something. If there are no questions, we just leave it here. So that's how we do open source code for research paper. But for package, it is totally different. So in addition to the core work, we also need to do a lot of side works, the documentation, the test, the examples, and the interaction with the community, and many others. So that's why, so in order to make the package to be successful, we need to have a very serious commitment to time commitment to make it happen. So, and finally, so after we have a package, right? So if we just put in the GitHub, so no one will cares. So no one will visit our site. So because it's like a cold start. So, in the GitHub, because when people search some good packages in GitHub, there's actually a IR system, information retrieval. They will search some keywords, okay, and find the package. And actually, so people will usually tend to prefer the package with more stars because they trust them. So if, for example, if you are in the GitHub and you search for a package, you'll find the package only have like less than 10 stars. You don't trust it, right? So you think, okay, maybe there's some problem in it. So however, although we have built a very excellent package, without some initial stars, there will be no users, the cold start problem. So what we do is actually, okay, we just ask our friends to give more stars and try to connect with the media and try to write some news article to advertise it. So at that time, I try to, because some of the games are actually some Chinese games. So we actually contact both medias from both the United States and some also Chinese medias. And then we do attract some attention. And we try to write a lot of news article, and we try to advertise, okay, our package is the right thing, so people should use it. And finally, we got more and more stars. And finally, and now we got more than 1,500 stars, so which is become a mainstream package in the poker game. So this is actually, so in this way, so the package enters a healthy loop. So because it already has a lot of stars, right? When people search some keywords like the poker game, Texas Hold'em, reinforcement learning. So okay, our project will be ranked relatively high, so that people can are more likely to use it and more likely to start it. So that's how, yeah.
I'm asking a question about the funding and media to write in this article. should the paper be published before this was prepared or after this was prepared?
Yeah, that's a very excellent question. So at my time, so actually, so because although we are doing a package, but this package actually also serves for the research purpose. So so we first write a very short paper and put in archive, and then we send this archive link to some media to say, okay, we have done something very great, and to ask whether you can help us to do some advertisement, right? So there are some media, so they also need some content, especially for some machine learning related media. They also try to find some good content to attract users, and you just try to persuade them, okay, your package can help them to attract more users, and then it's like a win-win benefit.
But do you need to give money to media?
So actually we didn't give any money, so most of people are willing to do this. So yeah, so but of course, if you can pay money, so more media will be very happy to do this. Yeah. So now I will discuss the problems we have faced. So it's not easy. So it takes maybe 1 or 2 years, and finally we make it popular. So the first problem I faced is the interface is not flexible. So as you mentioned, as we discussed before, it's really hard to design a really good interface at the first place. So yeah, because we cannot always think from the user's perspective. So when we collect more feedback, and we found that actually the interface is still very hard to use. So we just iterate again and again, so to make it better. And secondly is that there are too many issues in GitHub. So people, whenever people have questions, they will ask an issue. And sometimes we feel it's exhausted to answer each issue. So in order to make the package popular, we need to actively reply the issues, but it takes a lot of time, especially for PhD students. We need time to do research. We need to do TA stuffs. So it really takes a lot of time. So at that time, I just focus on the important ones. So for less important ones, I just let it go. And maybe other people will help you to answer all these questions. Although it is a very tough journey, but I feel it is very happy because I feel like I have accomplished something. So the feeling is a little bit different from the research paper. So research paper only has some impact on research community, but for open source project, you may have impact not only on research community, but also on the broader developer community. And also, of course, learn a lot. Yeah.
Apart from making interfaces, do you have any other recommendations to make the package more extensible? Like how to make the package more extensible, like other people contribute more easily to that?
Yeah. So for extendable, it's like we may need to look forward. For example, you can think about, okay, after 1 or 2 years, what the package will look like. So in this way, we can design some abstract method. So it's like we just write a method name here, and maybe use some documents to say, okay, so what we want you to achieve. But we may not need to achieve right now, but we can do some planning. And whenever we do the interface, we also think about the potential risks. So for example, if we do this interface, will this have some conflicts with some our future features? So we need to think about this. So my experience like so although we can look ahead, but we cannot be 100% correct. So maybe you plan it, okay, 1 year later it should look like this, but actually after half a year, so we kind of change the plan based on the users' feedback. So we just try our best to do this. So that's why not only on industry, but for open source project, it's also needs a lot of iterations. So we need to keep trying, and finally, and work with the users, and finally we converge to some point. So that's my experience. Yeah. So and finally, so because I talked a lot about RLCard in examples, I will introduce what RLCard is. So RLCard actually implement many games. So in the high level, we have several games, more than 3, maybe 10 games. And for each game, we use a environment class to wrap it. And this is RLCard. Yeah, in addition to the algorithm, in addition to the environment, we have also implemented several standard reinforcement algorithms, and to show some examples about how the algorithm could interact with the games. And this is the whole loop. So it's like for a user, from a user perspective, okay, user will first do some model training, and do some evaluation. And we have actually also provide some visualization tool, which is GUI, which I will show you later. And based on the visualization and debugging result and make some evaluation result, and people can debug their algorithm and improve it and keep training. So this is the main loop of how to use the package. So this is the old actually. So this is we have implemented 9 games now. Actually, I think now it's 10 or something. So these games have different kind of complexities and different kind of names and different kinds of document and also examples. So this is the interface. Then because this is my follow-up package, which is called a DouZero, so which is actually trying to build a reinforcement agent for popular Chinese poker game DouDizhu. So DouDizhu is actually maybe some people from China may know this. So it's actually extremely popular. So for example, there are more than 800 million registered users and 40 million daily active players on the Tencent mobile platform, which is the largest DouDizhu online platform in China alone. So you can see there's a lot of users. So, but however, one interesting thing is like for this game, it's very challenging because it involves both competition and collaboration. So to be more specific, there are 3 players in this game, and 2 players are called peasants, and the other player is called landlord. And the game is actually also called Fighting the Landlord. It's because the 2 peasants need to collaborate with each other and to fight against landlord. As you can see in this setting, we have both competition and collaboration. So the peasants need to compete with landlord, and the 2 peasants need to collaborate. So it's a really hard setting. So usually in the poker game research, most of the games are 0-sum or just only 2 players, just a competition. So there are very few works about collaboration. But at the time I do this, I did not observe any work about both competition and collaboration. And this is actually the GUI we developed. So it's like we have 3 agents and players can play the cards. So this GUI is actually very helpful, especially to attract a broader audience. So it's my follow-up work. So it's called DouZero project, and we try to train a strong AI system on the DouDizhu game and make it open sourced. So at that time, what I found is actually, so in order to make it very strong, we do not need a very advanced reinforcement algorithm. There are a lot of algorithms there. So, but we found that actually in the large scale game like DouDizhu, so the feature design is more important. So, which means as long as we use the right features to encode the state, the actions, the cards, and even if we use a very simple algorithm, so what we use is called the Monte Carlo method. So which is actually, so if you have taken the reinforcement course, so the Monte Carlo method is you will see it in the very maybe second or third class, because it's a very basic one and very simple. So, and then we apply this algorithm to achieve really good performance. And so the key contribution is actually how we encode the card. So for example, in DouDizhu, we have a hand card. So we try to encode them. So the idea of encode is to use a card matrix. So it's like, for example, in this matrix, and each column represent a specific rank. And there are, because in a deck of cards, there are at most 4 cards for each rank. So we have 4 rows here. And if there a specific card appears in your hand, we just make this entry as 1. And for the other entries, it's just 0. So it's like a 1-0 encoding. So that's how we do the encoding.
Oh, by the way,
yeah.
Technical question.
Oh, yeah.
How do we enhance the Monte Carlo method by neural networks?
Yeah, so yeah, sure. I would just talk about it. So this is actually the Monte Carlo method. It's really easy. So it's like just 3 steps. Okay, so first step, we generate an episode using the current policy, and then for each state and action appeared in the episode, we calculate the Q value. So Q value is actually it means, so okay, if starting from the state S and perform the action A at this timestamp, what is the expected value or reward we can achieve in the end? So it's very easy. So the idea of a Monte Carlo method is very simple, just keep sampling, right? So if we have enough samples and do the average, then this is what we want. So actually we have learned this idea maybe in our middle school. So the idea of enhancing this with deep neural network is like, so usually for the monocolumn methods is for tabular cases. So for example, for QSA, so we may try to construct a matrix. Maybe each row maybe represent a state and each column represent an action. Maybe we initialize them with 0 and we keep, and whenever we have new data, we update the entries, the values in the matrix. So that's how the traditional monocolumn works. But in large scale game, it's very hard because the state space and action space are extremely hard. It's impossible for you to construct a matrix for this. So what we do is like we design a neural network, which is shown here. The neural network will take state and action as input. So yeah. Sorry. What is the samples? Oh, the input is like a state and action. The state is like what we can see in the current state. So which means, for example, in a poker game, we can see, okay, what my hand card is. So what are cards already shown in the desk. So, and then we use this kind of method, the matrix, to encode what we see. So, and the other thing is the action feature. So which means in DouDizhu game, so it's like in each step, we can choose a combination of cards in my hand and we play it. So, and then we for each hand card, we can obtain all the legal actions, and each legal actions is is one of the combination of the cards. So it's like for each combination of cards. For example, in this we have 3, 10, and 1, 3, and we use the same matrix to encode these 4 cards. And then in this way, so input of neural network becomes many matrix. So actually, we can use more advanced neural architecture, such as the convolutional network or ResNet, because there are actually some local information. But in our initial work, we just use some MLP. We just flatten all the matrix, and then we just feed it into 6 layers of feed-forward neural network and predict the Q value. Yeah. Yeah. So because in the Monte Carlo methods, we actually, whenever we have new samples, we just recalculate the average, right? So in the neural network, we just use the mean squared error. So for example, we use the current network to generate, for example, maybe 1,000 batch of data, 1,000 observed Q value. And then we use the 1,000 value, use mean square error to update the Q value. So mean square, okay.
How do you get the sample to relate this state? You get a new sample each time and you compute the state.
Oh yes, that's right. It's an iterative process. So
right, but how do you get the sample? Or is it like a random second of all?
Yeah. So at the beginning, so we have a random neural network. And then we use this random neural network to choose the samples, which means given a state, we just calculate the Q value for each action. So Q value is an expectation of what reward we can achieve eventually. Of course, larger the better. And then we just simply choose the action with the largest Q value. But in the real implementation, there could be some other tricks. So for example, we need some exploration. So for example, if one action is pretty good and it will always choose that action, which is bad because we cannot explore other actions. So usually we will use some we will add some randomness. So for example, we will give, for example, for 10% probability, we just random choose an action. For 90% of probability, we choose the action that can lead to the best Q value. So the overall training is like an iterative process. So starting from the random network, we use the random network to sample some actions. Then we use this action to update the Q network. So then the Q network becomes better, right? So then we use the better Q network to sample more samples, and then we use these more samples to keep updated. And then after many iterations, it will become, it's like a self-play, and then it will become better. Yeah. Okay.
Doctor, we only have 5 minutes left, so try to wrap up.
Okay, yeah, sure. And this is the result. I just skip it. And yeah, so this is our demo. So you can actually play with it. So because we don't have time, so I will just you can try this by scan the QR code, which or you can try the DouZero.org. So you can just play with the game, like for example, you play with the landlord, and then
You have to learn how to play the card game.
yeah. So it's like if you are from China, you may know how to play it. So anyone want to have a try? So if you, yeah. So if no one want to try, I will just play it. Maybe, yeah, I will just a random play. So to give you an idea. So after we play it and there's a mode which called the AI head face up. So it will show, okay, so what the AI thinks. So they will try to think, for example, if we pass, the win rate is 77% or something, and then we just play, and in the end. So so the data from our backend suggests that our win rate, AI win rate is like 60%, which is actually better than the normal human. But in reality, we have also tried this to play with some expert human players, but it cannot win the expert players now, but it can win the average human players. Yeah, so, and there are some other times, so I will introduce my other projects. So in addition to the poker game, I also work on automated machine learning. So for example, one of the packages called Auto Video, so which use some algorithm to search the best pipeline to do the video recognition. So video recognition means given a video, we try to identify so what action it has been done. So for example, this girl is brushing her hair. So we just predict, okay, it's brushing hair. So the key of auto here is like, because it's hard to design the architecture and the data pipeline to achieve a good result. So we use some search algorithm to automatically identify the best design, best machine learning model for this problem. And similarly, we also do TOS. TOS is like a time series outlier detection. So time series data is like in the x-axis, we have some timestamp. In the y-axis, we have some values. And then we try to identify which is the outlier. For example, this point, this is called a point-wise outlier because this point is significantly different from the other points. And this one is called a pattern-wise outlier because this specific pattern is different from other patterns. It's a window perspective. So there are a lot of different kinds of outliers, and the data could be more complex because we may have high dimensional data. So the TOS project aims to use some algorithms to automatically find the best algorithm for the specific outlier types. And the other projects includes PyOS, which is actually also a outlier detection package, so which is an end-to-end outlier detection and with very good visualization of why it is an outlier. And the next one is called BAD. So it's like an embedding system. So we try to do object detection. Object detection means given an image, for example, this image is a plane, and we might try to identify where the plane is. Maybe we just use a bounding box to identify where it is and to tell people, okay, this is a plane. So this is the idea. So, but of course, we may have more objects. We may have people, we may have the plane, and we may have fruit or many others. So this project is about we try to use automated machine learning to search the architecture and compress the model size so that we can feed it into edge device, because edge device is not like the server. There are no GPU. They only have very limited memory resources. So we need to do some, it's more like a tiny AutoML. Yeah, that's all, the summary. So I feel like the open source is very fun because I feel like I accomplished something beyond research. So however, it requires a lot of efforts. So it requires a lot of time commitment, but I still love it. And the suggestion is like always have a plan and evaluate the risk before we move, so that we do not need to do very many redundant efforts. And finally, we welcome the contribution. So you can scan the QR code. This is my GitHub, and this is the GitHub of our lab. And you can see all the project in it. Okay, thank you.